Hey guys, welcome to section 5.1. This is our last review section. This is a section that talks about one-to-one functions and inverse functions. So just a friendly reminder, a function is a rule or a relation such that each input is assigned to just one output. Functions pass the vertical line test. FCN is my abbreviation for functions, and VLT is vertical line test. So all functions pass the vertical line test. A one-to-one function is a special function. So a special function such that each input has its own unique output. Right? One-to-one functions are, all functions are relations, but functions are special relations such that each input has just one output. A one-to-one function is a special function such that each input has its own unique output. Remember, with functions, outputs can repeat. With one-to-one functions, those are special functions where outputs don't repeat. How can we tell if a function is one-to-one? Well, graphically, one-to-one functions pass the horizontal line test. So let's look at the function y equals the absolute value of x. Beautiful function, passes the vertical line test. Every input has just one output. But this function is not one-to-one. I can draw a horizontal line right here, so it fails the horizontal line test. So it's not a one-to-one function. Notice right here, this is the ordered pair 2, 2. This is the ordered pair negative 2, 2. One-to-one functions, outputs are not allowed to repeat. Each output has to be unique to its input. All right, let's look at the graph of y equals x cubed minus 2. Great little squiggly thing. Notice no matter where we draw a horizontal line, it will always cross the graph just once. So each input has its own unique output. Passes the horizontal line test. Y equals x cubed minus 2 is a one-to-one function. Why do we like one-to-one functions? Well, only one-to-one functions have a corresponding inverse function. And as a reminder, inverse functions undoes what the action of the original function does. So inverse functions undo what the original function does. A function g is the inverse of a function f. If f of x equals y, and then we put y back in g, it's going to spit x back out. All right, so we use a different notation than f and g, though. So the notation we use for inverse functions, if g is the inverse function, that should just be inverse function of f, we write g is equal to f inverse. Now be careful, because this notation means something very differently when applied to a function as opposed to a numerical value or a variable. All right, so we'll go back to that in a moment. Let's find the inverse function for the function f of x equals x plus 7. So this function says we make an input, we make an output. Right, so if we put in, the domain is all real numbers. If we put in 0, we get 7. So we are looking for a function, another function. We're going to call it f inverse of x. such that when we put in 7, it's going to give us 0 back. So it's going to undo what the original function did. we put in 11, we get, we put in 11, we get 17. So if I put 17 in here, oh no, we don't, we get 18. Try again. If I put 18 in, we want to get 11 back. So if we just think logically, what function undoes plus 7? Well, hopefully you said minus 7. The inverse function would be x minus 7. So we take this output, we stick it into the inverse function, it should give us what we started with. So if I did -9, we'd get -2. Right? And then if I took -2 and stuck it into the inverse function, it gives me -9 back. So it undoes what that function does. So careful, be really careful with this notation. F inverse of x does not mean 1 over f of x. Okay, do not do this. Notice if for f of x equals x plus 7, its corresponding inverse function is x minus 7. Note, f inverse of x is not equal to 1 over x plus 7. So that inverse notation, this -1 superscript, only applies to the reciprocal if it's a variable. Like if we do 3 to the -1, then that's 1/3, that works. If we do a variable p to the -1, that's 1 over p, that works. But a function with a superscript of -1 means inverse function, it's undoing the previous function, and it's not 1 over. So it's just an abusive notation with mathematicians. I did not create that notation, so you can't blame me. All right, ready? So friendly reminder, algebraically, how can we find an inverse function? They're not always going to be easy as plus 7 minus 7. Whoops, well, I'm way off with my camera, sorry. All right, so let's see. So given, finding f inverse given f, right? So replace f of x with y. Switch all x's to y's and switch your y to an x. Solve what you just did up here for y. Then replace y with f inverse of x. So remember, what an inverse function does is just literally reverses the roles of x and y. If x is 0 and y is 7, then x becomes 7 and y becomes 0 in the inverse function. So we're going to literally just call f of x y, that is right as an equation, switch all your x's to y's and all your one y to x, because it's a function, there's only going to be the one y, and then solve for y. All right, so let's look at this guy. Let's solve, let's find f inverse for f of x equals 4x minus 6. So step 1, replace the f of x with a y, 4x minus 6. Step 2, we're going to switch all the x's to y's and all the y's to x's. I'm going to say x is equal to 4y minus 6. And then we're going to solve for y. So x equals 4y minus 6. X plus 6 equals 4y. Add 6 to both sides. Divide out the 4. We get y equals x plus 6 over 4. We could also write this as x over 4 plus 3/2, right? X over 4 and then 6 over 4 becomes 3 over 2. So therefore, f inverse of x is equal to x over 4 plus 3/2. Right? So let's just confirm. If f of x is equal to 4x minus 6, f inverse is x over 4 plus 3/2, right? All right, let's just double check. Let's do, I'm going to do, I don't know, let's start with 0. If f is 0, if x is 0, we get 4 times 0 minus 6, we get -6. All right, let's stick -6 in here. Well, negative 6 over 4 is negative 3/2 plus 3/2 is 0. All right, looks like we're off to a great start. Let's put 5 in, let's say. So 20 minus 6, 14. Right, if I put 14 in, 14 over 4 plus 7 over plus 3 over 2. Well, 14 over 4 is 7/2 plus 3/2, which is 10/2, right? And we'll just do it in here just to confirm, and then just to practice using your calculator too. So if I put 14 here, I'm going to do 14 divided by 4 plus 3 divided by 2. I get 5. There we go. All right, so just be careful you don't make silly mistakes because of algebra. So it appears to be working, right? But just a reminder, to prove two functions are inverses of each other, we can't just try two numbers. The domain of both of these is all real numbers. So we would